Hello. Okay, so we start the design of two-pass assembler. Okay, in previous class we have seen the design of one-pass assembler. In today's class we are going to see the design of two-pass assembler. Okay, so this two-pass assembler includes the pass-one assembler. Okay, and each pass have its own working. For example, pass-one separates the symbols, mnemonic opcodes, and the operand fields. Also, it builds the symbol table, it performs the LC processing, and finally, it constructs the intermediate presentation, that is IC. Okay, so what is the working of here? Pass2, that is synthesize the target program. Means what? The pass1 performs the analysis of your source program. Okay, it is taking a source program as an input and it converts that source program into some parts like symbol table, literal table, intermediate code, mnemonic opcode table, likewise. And in pass2, the assembler takes all these parts together and constructs the final target program, that is your machine code program. So we'll see in the example. So you can see here diagram of two pass assembler. You can see source program also, that is the input for the pass one assembler. It needs some data structures. Okay, what are the data structures? Like symbol table, mnemonic opcode table, literal table, likewise. Okay, and it constructs the intermediate code. So you have to remember that intermediate code is an output of your pass one assembler. Okay, now we are going to see the two pass assembler. So what should be the input for the two pass assembler? Okay, the output of your pass one, that is nothing but your intermediate code, is the input for the pass 2. Okay, and it finally generates your target program as a machine code. Okay, so it also takes the help from these data structures like symbol table, literal table, and it finally generates your target program. Okay, in this next diagram you can see pass 1 performs the analysis and pass 2 performs the synthesis. Okay, again the data structure example is given here, which is mnemonic table, okay, and symbol table. And by taking these two things, it generates the target program. This is the analysis phase versus synthesis phase. Okay, so this is the important point, which is pass 1 output and pass 2 output. So pass 1 output is always intermediate code and pass 2 output is always machine code. So consider a following example. We have seen this example before. Now again we are going to try to solve it. So this is our program which starts from the 200 location, and for first step is what? To find the addresses of all the variables. Okay, so how to find the addresses of all the variables? By applying your location counter. So I have added here one location counter which starts from 200 and it will increment by 1. Okay, again we have built already, that is symbol table and the literal table. Now we have constructed the IC also. Now our target is what? To generate the machine code. Okay, for the machine code you always have to consider the IS, that is imperative statements. Okay, the machine code is not generated for the ADs and DL. Okay, only for the imperative statements you are getting machine code. So the very first line is what? AD, 01, C, 200, and that is the assembler directive statement. So no machine code will generate. Okay. Next is what? IS04, RG01, L, 0. Okay. So for that I have 04 as IS, 01 as RG, and literal 0. That is L0 means what? The literal which are present at the index 0. So the address is what? 205. Okay. Similarly, next line IS05, we have to ignore the IS. Only 05 we have to write. Then RG01, again ignore the RG, write down the 01. And S, 0 means what? 0th entry in the symbol table. Okay. And the address you have to write 214. Okay. 0th symbol in the symbol table, and that's address 214. Next is again IS, 04. Again I have to ignore the IS. Again RG02. Again I have to ignore RG. L1 means what? First entry or first index literal and its address, that is 206. Okay, again AD is there, so no machine code will generate. DL comma 02 C comma 5. So here DL performs the storage things or the declaration. Okay, DL0T means what? Declaring a constant. Okay, so I have to only write about the constant, that is 05. Okay, so again 005 and next line is also 002. Okay, again next statement is again is. For that purpose I have to ignore is, RG and L comma 2 means what? The literal which is present at the index 2 and its associated address I have to write here 210. Similarly, you have to write for all full program so that you can get the machine code. Okay, you can observe here again the is, DL is what? DL02 means declaring a storage. Okay, so 01 is here and 02 is here. Okay, if there is a DL01 that is declaring a storage, then I do not have to write the machine code for that line. Okay, so because here DL02 means what? Declaring a constant. So I have to write 002. Okay, this is what the machine code generation in Pass2. So next point is what? The comparison between the Pass1 and Pass2. Okay, so very first point is what? Pass1 requires only one scan to generate the machine code. Okay, and Pass2 requires two scan to generate the machine code. Okay, as its name suggests us that Pass1 means what? One scan and Pass2 means what? Two scans. Okay, next difference or next comparison is what? It has forward reference problem in Pass1. Okay, we have already seen this topic, which is forward reference problem. Okay, that occurs in the Pass1 assembler. In Pass2 it don't have forward reference problem. Means what? As we are scanning our program two times, in second time scan I am getting all the addresses of the variable. So the presence of forward reference problem is not in the Pass2. It's not available in Pass2. Okay, now third one is what? It performs the analysis of source program and the synthesis of intermediate code. Okay, source program का ये analysis perform करता है and it synthesize the intermediate code in the Pass1. Again, Pass2 takes the IC as an input and synthesize the target program with the help of some data structures. Okay, so Pass1 is very faster than Pass2 and it is slow than Pass1. Pass2 is slow than Pass1. Okay, if we are talking about the speed, then Pass1 is very fast and Pass2 is very slow. This is what the difference between Pass1 and Pass2. Okay, so in this topic, in this session, we have seen all things about the working of Pass2 assembler. In next, we are going to see the variants of intermediate code, how we can write the intermediate code. Okay, so this is for now.